Hello, I'm Lavinia Heaton, and today we are graphing more linear functions, or on occasion some lines. If we have a vertical line, of course it's not a function, and we've already graphed some of those, so I need to comment that those were not linear functions, but they were lines. Okay, the first problem we're going to look at today is to rewrite 2x plus 6y plus 18 equals 0 in slope-intercept form. Now, if you recall, slope-intercept form means that it's solved for y. So to solve for y here, let's get rid of everything that's not y on the left side. So if I subtract 2x and subtract 18, then I'll just have 6y on the left, and I have to do the same thing to the other side to keep it balanced, the other side of the equals, remember. So it's negative 2x minus 18. And then to get 1y, we'll divide by 6, and we'll do each term individually, since the slope-intercept form requires two terms on the right rather than a single term. So y equals negative 1/3 x minus 3. And that's our answer for slope-intercept form. And remember that when we get it in this form, the coefficient of x is the slope, and m stands for slope. So the slope is negative 1/3. And the y-intercept is the constant here, negative 3, which implies when we get ready to graph, we will graph the ordered pair 0, negative 3. Because remember, if we're on the y-axis, the x is 0. So next we'll graph, and we'll be graphing our y-intercept as 0, negative 3. And then our slope was negative 1/3. Now I can think of negative 1/3 as negative 1 divided by 3, or 1 divided by negative 3. Now this says I'll rise negative 1, or go down 1, and write 3. So I'll go down 1 here and write 3, and that gives me a new point. Then we'll erase our trail here. Whoops, got them all erased. We'll get them back. 0, negative 3. And there are 2 points. Now, I don't think I want to go down any lower. I think I would like to go up. So I'm going to go with this right here, 1 divided by negative 3. So I'm going to go up 1 and left 3, and I have a new point. Up 1 and left 3, and I have a new point. Now, it only takes 2 points to determine a line, but 3 points helps me do my straight edge a lot better than just 2 points. So this is what my line looks like graphed. All right, looking at the next problem now, we're going to find the x-intercept and the y-intercept for the equation 3x plus 5y plus 15 equals 0. So let's talk about finding the x-intercept. Now remember, if we're anywhere on the x-axis here, anywhere, our y is 0 because we've moved up or down none. So we're going to let y equals 0 in the equation, and then we'll be able to find the x. So 3x plus 5 times 0 plus 15 equals 0. So we have 3x plus 15 equals 0. Subtracting 15 from both sides, we get 3x equals negative 15. Then dividing by 3 on each side, we get x equals -5. So our x-intercept is x equals -5, which implies that we'll graph -5, 0 when we get ready to graph. All right, next we want to find the y-intercept. And this time we'll let x equal 0 because anytime we're on the y-axis, we've moved left or right none and our x is 0. So letting x equal 0, we get 3 times 0 plus 5y plus 15 equals 0. So we have 5y plus 15 equals 0. Subtracting 15 from both sides, I end up with 5y equals -15. And dividing both sides by 5, I end up with y equals -3. So the y-intercept is y equals -3, which implies that we will graph the point 0, -3. So we're graphing 0, -3, and -5, 0. So let's move to our next slide and graph. So we had 0, -3. And let's see what else we had. We had -5, 0. All right, -5, 0. And there's our line. Now, I don't know about you, but if I missed one of those intercepts, I could have a problem, right? I could have the wrong line drawn. So let's do this. Let's write our equation again. 3x plus 5y plus 15 equals 0, and find another point. Now we have had -5, 0, and 0, -3 is our 2 points. Since our x's are moving by 5, why don't we try finding out what would happen if we let x be 5. If x is 5, we would get 3 times 5 plus 5y plus 15 equals 0. So 15 plus 5y plus 15 equals 0. 5y plus 30 equals 0. So 5y equals -30, y equals -6. Let's see what that point looks like. Go over to the right 5 from the origin. 1, 2, 3, 4, 5, and then down 6. 1, 2, 3, 4, 5, 6. That looks like it's on the line, doesn't it? I like to do this as a checkpoint, a third point, to make sure I didn't make a mistake. So let's label that checkpoint. And that way, if I made a mistake on one of my intercepts, I would be able to find it. Next, we're going to look at a graph here. It shows the percentage of the U.S. population never married, ages 25 to 29, for both females and males in the years after 1980. That means right here, this is 10 years after 1980, 20 years after 1980, 30 years after 1980, and of course our 0 years after 1980. So 0 would actually represent 1980, 10 would represent 1990, 20 would be the year 2000, and 30 would be the year 2010. We're going to use 2 points that were on the red line, and their coordinates are 10, 45.2, and 20, 51.7. And we're going to write the equation of the line that gives y the percentage of never married American males ages 25 to 29 in terms of x, the number of years. So let's see what an ordered pair looks like. Our xy, or either of these 2 points, shows x as the number of years after 1980, and y is the percentage of never married males. So it's a good idea to keep straight what the x and y in each of our points stand for. So this is 10 years after 1980, and 45.2% of the males were never married. Okay, let's get ready and write that equation here. Here are our 2 points. Now what is it we need to write the equation of a line? We need a point and we need a slope. So for our point, we're doing very well. Just pick one. So 10, 45.2. Since I used it first, I'm going to call that my x sub 1, y sub 1. I need a slope next. So first thing I have to do before I write the equation is find the slope. Now, if you remember our slope formula, m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So this up here will be my second ordered pair xy, and my slope is going to be y sub 2, 51.7, minus y sub 1, which is 45.2, divided by x sub 2, which is 20, minus x sub 1, which is 10. And then when I subtract, I get 6.5 divided by 10. So that ends up being 0.65 in decimal form. And since we're working in decimal form here, we don't mind having a decimal in our slope. So we now have the slope 0.65 or 0.65 if you like to make sure people notice your decimal. We'll write the equation of the line using the point slope form. Remember that point slope form looks like this. Y minus y sub 1 equals the slope times x minus x sub 1. So for our situation, y minus y sub 1, 45.2, equals the slope of 0.65 times x minus the x of the point. And this right here is in our point slope form. But we want this solved for y because let's look back at our directions. It says that gives y in terms of x. That means solve it for y. So y minus 45.2 equals, using distributive property, I get 0.65x minus 6.5. So now adding 45.2 to both sides, I end up with y equals 0.65x plus 38.7. And that's our equation now that we're going to work with in the next part of the problem. The next part says use the equation to predict the percentage of never married American males ages 25 to 29 in 2020. All right, the year 2020 is how many years after 1980? 40, isn't it? So using our equation, we're going to replace x with 40 for the year 2040. So let's rewrite our equation here. Y equals 0.65x plus 38.7. So y equals 0.65 times 40 when we think about the year 2020 plus 38.7. So now when we do the arithmetic, we find that y equals 64.7. And that implies that 64.7% of the males in the year 2020 were never married. This concludes what we're going to look at for this segment. Next time we'll look at parallel and perpendicular lines.